Hi, this is Irv Shapiro with the Dr. Vax channel, and today we're going to do something completely different. Instead of me presenting to you today I'm going to ask you to participate in a conversation about what computer-aided design program you like using, what works best for you, what doesn't work for you. So as soon as you're done watching this video, or if you're already an expert, do it now. Go to below this video and leave a comment. Share this video with everyone you know so we can start an active conversation about what's working and what's not for people that want to design things to print on their 3D printer. Whether you're designing a toy to play with your grandchild, or you're designing a bracket for an internet switch, an internet component that you will put up on your wall. It doesn't matter. Let's have that conversation. Okay, hold on. Let's get started learning and discussing something together. Okay, let's start this video by going through a brief Google slideshow where I'm going to define two types of modeling, two types of CAD modeling programs, and some of the characteristics of those. Then we'll do a demonstration of 3 of the 4 programs I'm going to present here today, and then we'll do a wrap-up. Okay, let's take a look first at an overview of CAD programs. CAD programs are fundamentally today divided into object manipulation, 3D object primitive manipulation programs, and parametric modeling programs. There are many other types. Some are called sculpting. There are other types of CAD programs. But for our purposes today, we're going to talk about 2 types. The first, in an object primitive modeling program, you take a 3-dimensional object, a cube, a sphere, a rectangle that's been extruded into a 3-dimensional space, a pyramid, and you stack those one on top of the other to build a shape. This is very much like a young child stacks blocks in order to build things. It's almost like building with Legos. In addition, you have the ability to cut spaces out of these blocks. And we'll show you how that's done. In a parametric modeling program, you start with a 2-dimensional drawing, an actual sketch, and then you extrude that sketch into 3-dimensional space. In addition, you can draw sketches that are used to cut material out of your 3-dimensional model. So in parametric modeling, you do a series of steps that often start with a sketch. That series of steps is also completely reproducible. In object-based modeling, most of the simpler programs do not keep a history of what you've done. So if you want to go back and rebuild something, you more or less have to just remember it. Object-based modeling programs are very good for fast prototypes, for conceptualizations, for getting a sense of things. Parametric modeling takes a bit more time. You have to start with a sketch. Now that sketch can be well-defined, called fully constrained, or it can be unconstrained depending on the program, and you may still be able to create a quick and dirty 3-dimensional object. The object modeling program that we're going to start with, called Tinkercad, is so easy to use, it's taught to 3rd and 4th graders. So don't tell me you can't learn this computer stuff. This is really, really easy. Whereas the parametric modeling program that we're going to look at is designed, one of them is designed for professionals by one of the largest companies in the world designing computer-aided design programs called Autodesk. Another is a completely free program, and a third is somewhere in between. But parametric modeling is special because it completely tracks every step you take, and you can reproduce those steps. Okay, enough here. Let's start with Tinkercad and take a look at how this works. Okay, let's look at the screen together and get started with Tinkercad. This is the screen you see when you first log in after signing up for Tinkercad. It shows you designs you've previously done. You can rotate those around. And here's an example of a design that I made for an X-Acto knife clip. An X-Acto knife is one of my favorite tools. This is a clip I designed in Tinkercad. So you can see you can design things that are very practical in Tinkercad, but this is still a very simple design. There's basically the rectangle, a cutout hole in the rectangle, a cylinder, and a cutout hole in the cylinder. So there were a total of 4 objects necessary to make this particular clip. Okay, when you first come into Tinkercad, after you leave the gallery, you'll see a work plane. That's a surface you build things on. I'm going to drag a box onto this surface. I can manipulate the size of that box. I can make it bigger or smaller. I can drag a cylinder onto the surface. I can move that up so that we can put it on top of the box. Right now it's not fully on top. There we go. I can look at this from the front. I can look at this from the side. I can go back to looking at it 3-dimensionally. Now I can drag a hole onto the space. I can rotate that hole to 90 degrees. I'm going to actually make the hole quite a bit bigger. And then going to position it in the middle of my cube. Let's rotate to look at it in the front. We'll move it down a little bit here. We'll look at it from the side. We'll look at it from the home view. If I select my cube and I select my hole and I group them together, the hole will in fact be cut out of my cube. So the operations in Tinkercad consist of primitive shapes that include text, which it does very, very well, and shapes converted to holes, which are used to cut out entities or holes in those shapes. When you click on a shape, you do see the dimensions of that shape. Let's click on that and click on any of the corners. You'll see the dimensions. And you can change the dimensions off here on the side. In general, as you saw with the X-Acto knife clip, you can produce very useful things. But if you get to a point where you have a very large number, significant number, double-digit numbers of shapes, it gets harder and harder to manipulate in Tinkercad because there's no history of what I've done. That's an overview very quickly of Tinkercad. Okay, now we're going to look at the first of 2 parametric modeling solutions. The first one is Freecad, and as indicated, it's a completely free open source initiative that's been going on for 10 or 12 years. It's on version 17. They list it as 0.17 because they still don't consider it ready for quite prime time. 0.18 should be coming out in not too long. And let's take a look at it. When you first look at Freecad, it's overwhelming. In addition to this first screen, which is not obvious what to do, where it's not obvious what to do, there are many workbenches. A workbench is a style of editing that you would use for creating a part or an object. The part workbench works in some ways like Tinkercad, but much more sophisticated. It's a 3-dimensional modeling tool. We're going to use the part design workbench, which is a parametric modeling tool. And so now that we're in part design, we're going to create a new page. It's unnamed right now, and it will tell you, recommend what you should do next. We're going to create a body, and then in the body, we're going to create a sketch. A sketch has to reside on a surface. We're going to put it on the XY plane, basically on the top or the bottom, and we'll click OK. Now we'll take and start drawing. So I'm going to draw a basic shape here, and I'll connect together my individual corners. When I mouse over a corner, it turns white, so I know it's connected. And we'll go down to here. And then we'll go over to here. And then we'll see if we can get this connected up here. Okay, now we have a basic shape. But this shape is not very precise. I did this very, very quickly. So the first thing we can do is we can fix some things by adding constraints. As an example, I want to make sure this line, which doesn't quite look vertical, is truly vertical. So I will put a constraint on it that it's vertical. I also know that what this dimension is. So I will put a constraint on it that that side has to actually be 15 millimeters. I know what the size is down here, so I can put a constraint on that this size has to be 25 millimeters. And I can continue along that process to add constraints so that my full model is fully defined. When a model is fully defined, you will not be able to manipulate the shape by dragging it around. You can see here that I still can change the shape because it's not fully defined. I can continue to define this model. I can make this 15 millimeters. And now the model is more constrained. You'll see all the constraints over here on the side. When a model is fully constrained, it will tell you that it's fully constrained. Right now it says there's still 3 degrees of freedom. So it's not fully constrained. For our purposes, however, that is good enough. So I'm going to close my sketch. And the sketch is 2-dimensional. So if I look at it via the various other views, as an example, I look at it from a side view, it looks like a line. From a top view, it does look like the shape we're looking at. From a 3-dimensional view, you can see that it's a single plane. To create a 3-dimensional object out of it, I have to extrude it. The term for extruding an object in Freecad is to pad it. So I'm going to click on pad. There's a little bug there. It's switch screen. And I'm going to set the pad at 15 millimeters. Oops. If I go over here and I click on fit, it will fit that in my screen. Now, if I wanted to make a hole through this, I could do that by selecting a surface and creating another sketch. And the sketch I'm going to create this time is a sketch of a circle. So position the center, define the diameter, and I can constrain that just like I'd constrain other items. In this case, I'm constraining the circle. I'm going to give it a radius that's 1/2 the diameter of 5 millimeters. And I could further constrain it as where it resides horizontally relative to this shape. We're not going to do that for right now. We're just going to close this, select this particular new sketch, and instead of doing a pad, I'm going to create a pocket. If I create a pocket that's the full size of the shape, I don't remember how big I made it, so we'll make it 30. Whoops. And now if I rotate around, we will see that I just cut a hole through that shape. This is called parametric modeling. The reason it's called parametric modeling is that I have here a complete list of all of the steps I've taken. So if I go back to this step here, I'm going to close that page so it doesn't keep coming up. And if I click on this dimension here, this constraint, and I make this 2 instead of 5, and then I close this, you'll see now that the hole is much smaller. That's called parametric modeling. There are really no limits of parametric modeling as to the complexity of your object, other than the memory and processing power of your computer and potentially the tool. Okay, that's an introduction of Freecad. Okay, now let's take a look at Fusion 360. In many ways, Fusion 360 is what Freecad will look like when it's all grown up. Fusion 360 is supported by Autodesk, a multi-billion-dollar public company, perhaps the leader in computer-aided design in the world. They have a range of tools for architects, 3D designers, mechanical designers, sculptors, artists. And Fusion 360 is their offering that's very well suited for 3D printing technologies. Let's take a look at it briefly. It has multiple workspaces, just as you would have workspaces from Freecad. We're going to use the model workspace, which is similar to the part design workspace. In the model workspace, you start with a sketch. You constrain your sketch just as you would constrain a sketch in Freecad. When you're done with your sketch, you then extrude your sketch to create a three-dimensional object. Fusion 360's fit and finish is excellent. I can highly recommend it, but as we'll see in a moment, it is quite expensive. It is a professional grade parametric 3D modeling parametric solution. Okay, let me quickly wrap up my comments about CAD programs for home. You'll see here I have 4 programs listed. We talked in detail about Tinkercad, Freecad, and Fusion 360. I did begin to look at a program called SelfCAD. Unfortunately, I wasn't able to complete that. I had a number of difficulties using SelfCAD. The concepts behind it are interesting. It is an object-based modeling with a bit of parametric-like modeling in it. It also includes a slicer, so it's specifically designed for 3D printing, but I couldn't get enough of it to work reliably to review it completely. Among the 3, you can see here that Tinkercad is completely free for now. It is owned by Autodesk, so they could change that in the future. Freecad is free and free forever. Fusion 360 is free for your first year as a hobbyist or a startup. You then have to renew for a free license. It's also free for educational use. There is some debate in the industry about whether they will keep it free for hobbyists forever. That's a chance you're taking. Why does that matter? Well, you're going to invest some serious time learning Fusion 360. The styles we talked about, ease of use, Tinkercad by far is the easiest. Any 4th grader can learn it. You can learn Tinkercad. You might have to watch some videos, but you can learn it. Learning one of the parametric modelers will take you a bit more time. Assume that you're going to be watching videos and playing around for maybe a couple days before you start feeling comfortable with them. In terms of capabilities, there's no question that the parametric modelers are more capable, they're more precise, they're less limited than the object-based modelers that I used. I did find it difficult that you're not able to print plans from Tinkercad. You can print plans and you can do full computer-aided manufacturing and drafting in either Freecad or Fusion 360. Support for mesh editing is available in a number of these programs. I've used Tinkercad very, very successfully to add lettering to models that I downloaded from Thingiverse for grandchildren's gifts. SVG support is interesting because you might have something drawn in Illustrator that you want to put onto a model. The only program I could find that where I could do that reliably was Fusion 360. Tinkercad claims to do it. I was not able to get it to work precisely, and they all offer a free trial. Now, there are many other programs available. Here is a list of some of them. However, I did not review these in detail. Please leave comments about your impressions of these programs. So, what is my conclusion? Well, it's complicated. Everyone should learn Tinkercad. It's a delight to use, it's easy to use, but if you have models that are going to need more than maybe a dozen or so objects or steps, it's going to be hard to build very complex models in Tinkercad. If money is no object, or if you believe that Autodesk will leave their hobbyist, nonprofit, educational licenses free forever, you should learn Fusion 360. It's a delight to use. On the other hand, Freecad is an up-and-comer. It is a solid program. There's a bug in the current version on Macs, 10.14 on startup. There are a number of workarounds for that. I'm sure it'll get resolved quickly. I expect they'll also be releasing the next version, 0.18, before long. So learn Tinkercad. If you want to play around completely for free with a parametric modeling tool, you can do that with Freecad or Fusion 360. If you're betting on a program you're going to really get into and you're concerned about the Autodesk license, Freecad is a good alternative. Please leave your comments below. That's the most important part of this video. Let's start a conversation. Recommend this video to other people so we can include them in the conversation. Thank you. Let's continue to learn things together.